what happens when this material hits the sand, or if it was to hit sand, you've got something coming in at 30, 40, 50,000 kilometres per hour and it hits sand. A huge amount of energy is released as heat. Now, if you get sand, glass is basically molten and highly processed sand. So if you heat this sand to very high temperatures, it'll convert it into glass. And this particular type here is called green moldavite. It has a characteristic green colour. You might see it, a little bit of light shining through it. You can see it's green. The reason they call it moldavite is because it landed in an area that used to be called Moldavia. So the actual impact was in southern Germany, down here. But this particular material was found in the Czech Republic. So the meteorite hit in Germany and it threw material all the way across to the Czech Republic. That's how much energy. You imagine trying to throw a stone from here to South Australia. It's actually further than that. Or if it was to land in normal white sand, the sort of stuff that you see on the beach here. This is a material they call Libyan desert glass. So this is just normal yellow sand, and the heat has converted it into this white glass. If it lands in some sedimentary rock, you can actually melt it and preserves the layers. You can still see the layers in this rock. So it's converted that sedimentary sand into a type of glass, but it's preserved all those layers in the material because it's heated the sand and converted it into glass. They call that a flattle or pancake stone because it's flattened. It's like layered, like a pancake. Yes, flattle's better. It's more impressive to say flattle. What if, instead of sand, what if it lands in rock? Like basalt or something like that, normal everyday rock. You've got so much heat, so much energy in these impacts. It's like a volcano, it will melt basalt into a liquid. It'll throw this molten rock up into the air. So you imagine these balls of molten rock and the surface tension is pulling them together like a raindrop, forming them into a ball. And then as this goes through the air, it lands on the ground and goes plop and flattens because it hasn't completely solidified. So that's a piece, it would have been just normal granite or something like that. It's been converted to a glass, to a liquid, been thrown out of a meteorite impact, pulled into a ball, and when it's landed on the ground, it's been flattened. Or imagine this material, if it was spinning as it's going, the centrifugal force would pull it out into an elongated sort of a shape. So you imagine this is spinning as it's going, freezing, getting colder and colder and solidifying, and then just lands on the ground, just like that. Creates a dumbbell type shape, so it's got two thickened ends. Now that's okay if all the material that's near the surface, it can get blown away, it can escape, it gets thrown around the planet or somewhere. What about the material on the bottom? It can't escape, it's there, this huge rock that could be a kilometre across is coming in at 10 kilometres every second and hits the ground. The huge amount of energy travels through the ground for kilometres and kilometres, shatters the rock. It actually compresses it by 75% almost instantaneously. So you imagine a kilometre of rock is squashed to 250 metres high almost instantaneously. Creates a huge amount of compression and fracture, and then the rock rebounds and flies out of the hole. And this shattered rock creates what they call a shattered cone. You can see the meteorite coming in here and the energy is radiated down in a cone shape. And this could be kilometres and kilometres deep. So the energy travels through the ground, and you can see it creates shatter lines all through it. You can see all those little shatter lines throughout the whole. This could go for kilometres and kilometres. It's in limestone actually. That's what they call a horsetail appearance. It looks like a horse's tail with all those lines. So where have meteorites hit the Earth? You can see here, Australia's had their fair share. So has Europe and so has America. Right? They've hit everywhere. We'll go back to that one in America I talked about, one called Briars crater in Arizona. This is a piece, that's a piece of the meteorite that made that hole. It's only a small piece of it, but that's a little piece of the meteorite from Arizona. Now, that particular impact happened around about 40,000 years ago. To give you an idea how big the hole is, from one side to the other is 1.2 kilometres. So it's a hole in the ground. But the rock that made that hole, 1.2k in diameter, was only 50 metres. So it was only a bit bigger than this shed. And it made a hole in the ground that would go from here probably to about the gate when you go out tonight, just from a rock this size. It would have been the equivalent of a 2.5 megaton nuclear bomb going off. But it's interesting, as I said earlier, the meteorite never actually hit the ground. It came in, before it hit the ground, it exploded into many, many small pieces, and the actual explosion front blew this hole in the ground. They've dug in the base of this many times and they've never found the big meteorite itself. All they've ever found is tiny little fragments everywhere. There's tiny little balls of iron about this sort of size, about the size of a pea, everywhere. They think it got so hot the iron was turned into a gas, and then the gas condensed and it rained iron droplets after the impact. What if it was really big? Not a meteorite the size of this room, but really big. What if you were to get a meteorite 10 kilometres in diameter? It would be so high, so big. If a meteorite this size was sitting on the ground, a jet aircraft, a 747, if you've ever been in one, you know how high they get once they get to their cruising altitude. A jet at that altitude would just make it over the top of this one rock. Just. That's how big that rock would be. It would weigh 34 billion tonnes, or about 10,000 times what Earth's rock weighs. It would create a temperature of 20,000 degrees. The surface of the sun is only 6,000 degrees. It would be travelling at about 10 kilometres per second, 10 times faster than a speeding bullet. So fast even Superman couldn't catch it. It would release 100 million megatons. The bomb that they dropped on Hiroshima was 20,000 tonnes. This is 100 million tonnes. Millions of times more than our most powerful explosion. It would create enough energy that you could get all the water in Port Phillip Bay and turn it into steam, boil the whole of Port Phillip Bay 50,000 times. Then most of you know how big Port Phillip Bay is. 50,000 times that much water will be turned into steam. If it hit Melbourne, the crater would go from Ballarat all the way down to Warragul. So you would not see the other side. It would throw so much material up into the air that it would darken the skies for a few years. So it would be pitch black even at midday. Some of you probably know what I'm talking about here. But archaeologists and paleontologists and that have noticed that around the world there are lots of areas where they can find dinosaur bones. And there was this black material, a layer only maybe this thick in some places, and on the other side there were no dinosaur bones. So there were dinosaur bones below this black material and no dinosaur bones on the other side. So they knew there was something about that. And they called it the KT boundary because was between the Cretaceous and the Tertiary, which is when there were dinosaurs and when there weren't dinosaurs. This is just like a black clay. This is a piece of the KT boundary. So that's the sort of material that they found all around the world. And they found dinosaurs underneath this material, but there were no dinosaurs on the other side. So they knew it had something to do with it. And then some astronomers in the 1980s analysed that material and found that it had large quantities of iridium and platinum, which are very common in large asteroids and meteorites and meteoroids, and they're very uncommon on the Earth itself. And so they speculated that maybe it was caused by a huge meteorite impact. But they thought a meteorite this big would have to leave a hole even now. You would still be able to see the hole. And then as they started to use satellites to image the Earth, they found, just on the edge of the Yucatan, which is Mexico, so here's Mexico around here, they found this remainder of a huge hole in the ground. When they went there and they aged the rocks, they found that this hole was about 65 million years old, the same age as when the dinosaurs died out. So all the bits came together. They found the final bit they needed, which was a hole in the ground. So that's the current leading theory as to what caused their extinction.